special right triangles. Ooh. Good morning, friends. We're going to keep exploring our triangles today, and we're going to start it off with the Pythagorean theorem. I have total faith that you've seen this before in other math classes, and it is not strictly a geometry thing. It's very famous. I've heard you recite it before, but the only way it works, and the only thing that we're working with from now on, because we are trigonometrists, is right triangles. So if it's not a right triangle, we are not doing what we're supposed to be doing, and it probably won't work. So first off, a squared plus b squared equals c squared, the extremely famous Pythagorean theorem. The one that we need to watch is c. C is always the hypotenuse, and aka the longest side. So whichever side of the triangle is the longest, that is got to be our C. If it's not our C, then we are messing up the equation and it doesn't work. The other thing to think about is that the hypotenuse is always opposite the right angle. So, since the right angle in a right triangle is the largest angle default, it's always going to be opposite the longest side. And just a couple quick examples of this. If I was looking for x here, well, what's my longest side? It's definitely x, so I'm going to go ahead and put x squared on this outside part because that's my c. Then I've got 10 squared plus 24 squared. Next up, we're just going to square these numbers. I get 100 plus 576 equals x squared. I'm going to add them together. And one of the biggest problems I see people do at this point is say, oh, just divide. No, don't divide. We're not dividing. The opposite of squaring something is square root. And once I square root it, I end up getting 26 equals x. Boom. Now see, I would venture that a lot of people would say, oh, there's x. I'm going to go x squared equals 15 squared plus 9 squared. And I hope you already realize this. No! Why is this a massive no? Well, if you look closely, this would be the right angle, yeah? And they will always be clearly labeled and everything. But this is the right angle, and it's opposite 15, which means that 15 has to be the longest side. And I don't feel that we really need to do this one too, but it would be more like this. This up here, pure wrong. Biggest pitfall. All right, let's just finish it out. I get 81 plus x squared equals 225. When I subtract 81 from both sides, because I want to get x squared by itself, all right, we're going to move up here. And I end up with x squared equals 144. And the opposite of squaring is square rooting. And we end up with x equals 12. Be careful. The opposite side I keep talking about is exactly what it sounds like. If I was looking at angle P, we would go across the way. It's the side across from the angle, just like this arrow is implying. And also notice that side SR, it's not a part of the actual angle P. Whereas like SP and RP, they are sides of the angle. SR doesn't really have anything to do with it. Also, the way I like to think about it is if I made angle P bigger, if I made the actual angle larger, SR would immediately become a longer side because of it, because they have that relationship. So for angle P, the opposite side is going to be side SR. And we sort of just answered this question, but angle size and the side lengths correspond, meaning that the shortest side is opposite the smallest angle. You can see that here with angle P. Whoa. Angle P is the smallest angle in this triangle, and SR is the smallest side. So that means that the longest side, the hypotenuse usually, is across from the, I'm going to write it down here, largest angle. And in the case of the right triangles we're using, it always means that it's the right angle. So we've got two different special right triangles.